Okay, now it's time to find the percent composition or from the percent uh, of a hydrate. It has water in it, H2O. So our formula is going to have waters in it. And I'll show you this at the end. So it's a percent composition. Percent turns into empirical formula. The way you do that is what we've been doing all along. You divide by the mass that you find on the periodic table. Copper, rounded off to 64. Sulfur, round off to 32. Oxygen, 16. And water, scratch, scratch, scratch. Water's not on the periodic table, Mr. G. You're right, it's not. H2O is a formula. We have to find the mass of water. How much does water weigh? Well, we have H's and O's. 2 H's, 1 O. H each weigh 1. Oxygen weighs 16. 2, 16, 18. So that is the molar mass of water. We're going to keep water as a separate entity over there for now. Obviously, we had to do something strange to get its number, so we're going to save that. So let's just keep that in mind that that's a little separate, something special about that. So we do what we were doing before finding the empirical formula, same thing. So we take out our calculator because I can't do this in my head. We have 25.3 divided by 64 gives us 0.395. Close enough. 0.395. Those are moles, but it's okay. We don't have to write anything down. Looking for the numbers for now. 12.9 divided by 32 gives us 0.403. They look like they're the same number, don't they? Mr. G, one's a 0.3 and one's a point. They're the same number. 25.7 divided by 16 equals 1.61. Oh, that's definitely not the same number. And just for giggles, we do the other one also. Not we have to do that. 36.1 divided by 18 gives us 2 for waters. So we have to divide by the smallest number. Out of those numbers, what is the smallest? It would be this one. 0.395 is going to give us a 1. 0.395, you can use a calculator if you want, but it's going to give you 1. 0.395, that I don't know. And 0.395, I don't know. So I need a calculator. So let's see, 1.61 divided by 0.395 gives us 4. Nice whole number. So we have 1, 1, 4. I hope this one's a nice whole number. That would be really nice. 2 divided by 0.395 gives us 5. Another whole number. Okay, so good. We have nice whole numbers. How convenient. So, keeping water aside just for a second, let's do the formula for this one. We have copper. There's one of them. Cu1. Sulfur, one of them. S1. Oxygen, 4 of them. O4. It's a G. You don't write ones. You're right, I don't. So this part of the equation is copper sulfate, CuSO4. But Mr. G, what about the waters way over there? Yes, there are. There are 5 waters. 5 H2Os. But Mr. G, what do I do with those 5 H2Os? Well, this is something called a hydrate. It gets special treatment because the waters are waters in the crystal. And I'll show you crystal in a second again. But the way we write it is we use this giant dot, which is kind of like a multiplying thing. All it's saying is that these 5 waters, 5 H2Os, are attached to this copper sulfate in its crystal form. It is a hydrate, which means in a solid crystal, and here's copper sulfate, here it is. In this solid, beautifully blue crystal, this is copper sulfate, which you see behind you. Pretty blue crystal. It has waters in it. It's not wet, but in the crystal, there are waters. If you heat it up really hot, the water comes out, and here it is. The water comes out, and it forms this light blue powder, which has no waters in it. That is the anhydrous. So we have a hydrate and anhydrous. And here we have a hydrate with 4 waters, anhydrous without the water. So that is how you do a hydrate. Tough, but once you know how to do it, it's not so bad.